getting good at solving linear equations mostly just comes down to being able to set things out in a really clear, logical way, and to think of your equation as a balancing beam or a seesaw and keep things balanced. So whatever you do to one side of the equation, you do the same thing to the other side to keep it balanced. Now, I want to give you an analogy, and this is important because when we start with really simple equations, the natural tendency is to not use the proper setting out or the proper method that I'm going to teach you, and instead just spot the answer. Okay, now the problem with doing that is that it's really okay to do it with a simple equation, but if that's your only method, you'll get stuck as soon as things get harder. Now, if you've ever been abseiling before, I want you to picture what an abseiling instructor does before they launch you off that cliff. They show you the mechanism, how it works. You practice feeding the rope through the carabiners and things that you have in front of you, your figure of eight. And you're asked to walk backwards just on a fairly flat bit at the top of a cliff, leaning back and getting the hang of how it all works. And that's really important, isn't it? So that when you're actually on the vertical part of the cliff, you know what to do and you're going to be safe. Now, not many people during that whole showing of how to walk backwards and practicing using the gear, not many people would go, oh no, I've got a better way. I can just walk. Look, see, it's not even vertical. I can just walk here on this bit of cliff. I can just walk backwards. I don't need to feed the thing. No, people don't do that because they know that they're only learning this skill on the easy section where it's flat, so that when they're on the vertical part, they're going to be safe. Same thing applies here. I'm going to teach you the proper way to do this so that when we're on a really hard one, it's like the vertical part of a cliff, you're going to be able to deal with it. Because if you just say, oh, no, I can just spot the answer, it's a lot like that person who's refusing to learn how to use the equipment properly and just saying, no, I can just walk. It's not even steep here. Okay. So if we're thinking of an equation as a balancing beam or a seesaw, and we're looking at our pronumeral, in this case x, and we're trying to get it on its own so that we have it really simple. We have a seesaw that has x on one side and a number on the other. So we can say x is equal to this. We can think of it as x almost being kind of dressed up or put in a disguise. And our job is to get rid of that disguise and work out what the x is equal to when it's not in disguise. Now, here the disguise is it's had 3 added to it. So always think of looking at the pronumeral, figure out a little story. What's happened to this x? Oh, it's had 3 added. Now, what is the opposite of adding 3? How do we undo it? We subtract 3. So we can see that to get the x by itself, we just need to kind of disappear this plus 3. And we can do it by subtracting 3. Now, my setting out is I put almost like a little grace note in music, just a little note to myself. I'm going to take away 3 from this side. But to keep things balanced, I have to take away 3 from this side as well. Okay? Now, the 3's are going to be gone, aren't they? If I've added 3, but I've also taken it away, it's disappeared into a puff of smoke. And the only thing left on the left-hand side of this equation is my x. But on the right-hand side, I've got 10 minus 3, which I know is 7. Now, much easier would have been to say something plus 3 is 10. Oh, why did you waste all that time? I can tell it's 7. We're trying not to spot the answer. We're trying to use a logical method so that when things get tricky, we know what to do. Now, when things get harder, this same method tells us what to do. This question here is really no harder than the other one, except that it's harder to spot the answer. If I tell you you can use your calculator, you might still be a bit unsure exactly what to put into it. But let's tell a story. What's happened to this x? It's had 117.2 added to it. How do we undo that? We'll take away 117.2. But if we're doing it to that side, we have to do it to this side as well. That will leave the x all by itself over here. And on this side, I can now put into my calculator negative 84 minus 117.2, and I get my answer, negative 201.2. Okay, so your calculator can help you, but it's more about coming up with the process. All right, here we've got subtracting instead of adding. What's the opposite of minus 5? Adding 5. So we need to add 5 to both sides. Now adding 5 to this side will just disappear the minus 5, won't it? That's why we did it. That leaves us with x all by itself. And on the other side we have 12 plus 5, which is 17. Now sure, I could have solved this by saying something minus 5 is 12. What could it be? I know, 17. But instead I've applied my method, okay? So that when it gets harder, And I have one to do that might be a little bit more tricky. Maybe it's got negative numbers in it. I might have x minus 3. Now, this time the x is on this side. Doesn't matter. What's the opposite of taking away 3? Adding 3. So I need to add 3 to this side and add 3 to this side. That leaves the x all by itself here because the minus 3 and the plus 3 disappear each other. So I have the x on its own. And on this side, I've got negative 10 plus 3. Now, if you struggle with negative numbers, chuck it into your calculator and you'll see that you get minus 7. Now, if minus 7 is equal to x, you can also write it around the other way. X is equal to minus 7. That's a little bit like a seesaw where both the people have just swapped sides. All right, what about if we are multiplying the x by something or dividing the x by something? Same thing, just think of what the opposite operation would be. So the story here is that x has been multiplied by 4. What's the opposite of multiplying by 4? Dividing by 4. Now the easiest way to do it is like this. Divide by 4, divide by 4. Whatever we do to one side, we have to do to the other. Now if you had x, let's just say it's any old number, if you've multiplied it by 4 and divided it by 4, those two things undo each other. They cancel each other out, a little bit like they did up here. So we end up with the x by itself, which is what we wanted, and 20 divided by 4 is 5. Now, you might have been able to just say, hey, 4 somethings are 20, 4 fives are 20, but that's spotting the answer. We want to instead apply a nice system. Now, the reason that I prefer to write it like this, another way we could have done it, would be to say, hey, if 4x is equal to 20, then why don't I divide this side by 4 and divide that side by 4? The reason I don't like that setting out is it's harder to spot that these 4's cancel on this side, whereas when you see it like this, it's much easier to tell that the 4 on the top and the 4 on the bottom can both be crossed out. Also, here, I know that 20 divided by 4 is 5, but what if it didn't work out perfectly? What if we had a question like 3x is equal to 20? And you're saying, yeah, but I'm not sure what 20 divided by 3 is. It doesn't work out perfectly. Well, with the setting out that I was suggesting, divide by 3, divide by 3, these cancel. X is equal to 20/3. You can actually leave your answer exactly like that, and it's fine. You could convert it into a mixed numeral, but it's really not necessary to do so. So finishing off these sorts of questions with a fraction is a good idea, and you can simplify it if you can. If you're not sure, chuck it into your calculator. 20 over 3, hit the equals button, and it will simplify it for you if it can be done. All right, here the x has been divided by 6. What's the opposite of dividing something by 6? Multiplying it by 6. All right, the setting out for these sort of ones, I think it's probably easiest. You write the question down. Always have to write the question with an equation because it's your starting point. But you can do work on your question. For example, look, here I wrote 3x equals 20 as the question, but then I started to divide both sides by 3 right on the question. I sort of made it all messy. That's okay, it saves you time, and anything that saves you time allows you to do more questions. So if I can see here that to undo this dividing by 6, I need to multiply both sides by 6, I think the easiest way to do this is just to put 6 times on that side, and then times by 6 on this side as well. Now we can see that just like these 3's cancelled here, so will the 6's. Because if you're dividing something by 6, but you're also timesing it by 6, those two operations undo each other. So now we've got the x by itself, which is what we're after, and we know that 2 6's are 12. Okay, now when I first wrote that something divided by 6 was 2, sure, you could have maybe spotted, oh, I know, 12 divided by 6 is 2. But this method allows you to solve things much more easily when the numbers are nasty. So let's say we've said x divided by 3.4 is equal to 5.1. Much easier now to have a method. What do we need to do to undo this divide by 3.4? Times by 3.4. But if I'm doing it to one side, I have to do it to the other side too. Now we know what to do. We can cancel these 3.4's out, and we know that the x is now by itself, and now we've got something that we can put into our calculator to figure out the answer. Now, most of the time, Maths ends up being not so much about being able to make the calculation yourself, feel free to use your calculator for that. It's about knowing what to put in the calculator, and this gives us a method.